Hi there, we're looking at the arithmetic sequence section from C1, and in particular deriving the sum for an arithmetic sequence. So the chap on the left is Frederick Gauss, and when he was a lot younger than that portrait, his maths teacher gave him the task of adding up all the numbers from 1 to 100. The maths teacher basically chose it as a task to keep his class quiet. However, unfortunately, he had Gauss in his class who came back within about a few minutes with an answer. And what he essentially did, I'll show you for 1 to 10, was he took the numbers that he was required to add up and then he reversed them, and then he added them together. So this is the sum he was asked to find. He wrote it backwards and then added the two together to get basically double the sum, which ends up being the same number added together. Oh, little mistake there at the end. It's the same number added together that many times. So if it was adding up 1 to 10, it'd be 10 times. So that equals 11 10 times. So he discovered a very quick way of adding up numbers that go up by the same amount each time. And he could just divide it by 2. So the sum is 55. Now you need to be able to do this more generically for your exam, so we're going to look at it in a more general case where we've got an arithmetic sequence which, bear with me one moment, we've got an arithmetic sequence which starts on A, so A is the first term, goes up in D, so D is the difference, and the number of terms is n. And this is true for all of the arithmetic sequences that you'll deal with in C1. These terms are general. So if we take Gauss's approach and take our sequence, which will be A, the second term will be A plus D, the third term will be A plus 2 lots of D, and this carries on up until you get to A plus n minus 1 lots of D. The reason it's n minus 1 is that the second term has 1 lot of D, the third term has 2 lots of D, and so on. So the nth term will have 1 less than n lots of D. So there's our sum. If we write the same thing but backwards, the penultimate term would be A plus n minus 2D, and so on. We end up with that. And what you notice, if you add these two together, you'll get 2s, and this term plus this term will be 2a plus n minus 1 lots of D. The next term, this one here and this one here, would also be 2a plus n minus 1 lots of D, and that will continue all the way to the nth term. And what you end up with is that 2 lots of the sum will be n lots of 2a plus n minus 1 D. So finally, if you just divide everything by 2, this is the general formula for the sum of an arithmetic sequence. So this is the sum of an arithmetic, that's a sequence that goes up with the same amount each time, sequence or series. And you need to be able to carry out these steps in your exam. That would be core 1. There we go. Best to review it and try and practice it a few times. Hope that was useful.